السلام عليكم ورحمة الله وبركاته والصلاة والسلام على سيدنا محمد وآله وصحبه أجمعين. We will continue with tahsili chemistry, and today I will talk about redox and its application, which is electrochemistry. Okay, so what is redox? Redox is two reactions, which is reduction and oxidation. Okay, so first we need to compare between reduction and oxidation. So what do you need to know here? First, what is the reduction? Reduction, it means that this substance will gain electrons. So reduction, it means gaining of electrons, and oxidation, it means losing electron. So if the substance will be oxidized, it means it will lose electrons. If the substance will be reduced, it means it will gain electron. Okay, so let's take an example here, like B, substance B with electrons, so it will convert it to P minus. So here it gains the electrons in the reactant. That's why this is a reduction reaction, where A plus or A, it will convert it to A plus electron. It means this substance A lose one electron, so electrons in the real product. So this one is an oxidation reaction. How to differentiate between them, or how to know that this substance is oxidized or the substance it has been reduced? So here we need to check the oxidation numbers. Oxidation number for each one of them. If we are oxidized, the substance will be oxidized, so it means oxidation number will increase. And the oxidation number is the number of the electrons that will be reduced or gained during the chemical reaction, so it will be written here. Okay, and here the oxidation number will be reduced or decreased. Okay, and to know how the oxidation number will be increased or decrease, so here we have 0, we have positive numbers, and here we have negative. If the oxidation number will be moving in the direction of the positive number, so it means this one will be increased, so this one will be oxidation. If the oxidation for the substance will move towards a negative number, so this one is decreased, means this one is reduced. So it means that maybe I will move the oxidation number, will change from +1 to +3. So it means this one increases, one will be oxidation. If it moves from or change from +1 to 0, so it will decrease, so this one will be reduction. Okay, let's continue again with reduction and oxidation. So this one will be reduction here, and here we have oxidation. Okay, so what is the substance that will be most likely to be reduced? The substance with high electronegativity. So it has the ability to attract electrons, that's why it will be reduced. And the substance will be most likely to be oxidized, the substance with low electronegativity. Okay, the substance that will be reduced, it will be called oxidizing agent. And the substance will be oxidized, it will be called reducing agent. Okay, let's take an example and see which one will be, which element or substance will be oxidized and which element will be reduced. Na plus Cl2, it will convert it to Na plus Cl minus. Here I just need to balance this one. Okay, let's check the oxidation number for each one of them. This one is Na is an element. It doesn't involve a chemical reaction, or doesn't start a chemical reaction yet. It's not forming a bond, so it means oxidation number will be 0. For Cl2, it's also an element. It doesn't start a covalent bond or any bond with any element or an ionic, so it means it will be 0. Oxidation number will be 0. Here the oxidation number is +1, and here the oxidation number, it will be -1. Let's check for sodium. So for sodium, here we're changing from 0 to +1. It means the oxidation number is increased, so this one is oxidized. So we have an oxidation here for sodium. And for chlorine, it decreased. It means this one has been reduced. So we have a reduction here. So this one gain 1 electron and this one lose 1 electron. So it means that sodium will be the reducing agent and chlorine will be the oxidizing agent. Okay, so how to determine the oxidation number for elements? So actually we have rules to determine the oxidation number of element. I will just say the most important one. What do you need to know when you are calculating the oxidation number for any element? So first, oxidation number, or sometimes it's called the oxidation state, for any element which is the element is not included in any bond. So it means like Na, like H2, like Cl2, like O2, like Hg. This is a pure element here. So it means oxidation number will be always 0. Okay. We have fluorine, and the oxidation number for fluorine is always -1. Okay, for oxygen, okay, actually for oxygen we have 3 cases. The normal case, which is most found, it will be -2, and sometimes oxygen will take -1 in the peroxide. And what is the meaning of peroxide compound? Where he will combine with element number or group 1. Will form like H2O2, like Na2O2. So we will have 2 of the element and 2 atoms of the oxygen. This will be called a peroxide. And most it will be formed with group number 1. In that case, oxygen will be only -1. And oxygen could be a plus or a positive oxidation number when he will combine with fluorine. So it will combine with fluorine, so it will take a positive number or a positive oxidation number, because fluorine is more high electronegative. So this one will be a negative, which is fluorine, and so the oxygen will be a positive. Okay, for hydrogen also we have cases. For hydrogen regular one or regular oxidation number for hydrogen, it will be +1. And we have case here where the hydrogen will be a -1. When hydrogen will be a -1, will it be combined with metals like NaH. So in that case, the metal will be the positive and the hydrogen will be the negative. Okay, so we should know also that group 1 will be always, all the elements will be +1. Group 2, in the periodic table, all the elements will be +2, and aluminum will be +3. So this is xenon here. So we need to use this information in order to calculate the oxidation number of any other element. So any other element except fluorine, oxygen, hydrogen, and group number 1, group number 2, they will be unknown. Okay, so let's take an example and see how to calculate the oxidation number. If we have NO2 and we want to calculate the oxidation number for nitrogen, so we know oxygen, and we know that oxygen has 3 cases. This is not the peroxide and this is not fluorine, so it means that oxygen will be -2. So it means I have 2 oxygen and each one of them will be -2 plus the nitrogen, which is unknown. This will be equal to what? So here this one is a compound. If we didn't find any charge for this compound, this is not an ion, so the total of the sum of the charges or the sum of the oxidation number should be equal to 0. So I have 2 oxygen, each one of them will be -2 plus nitrogen will be equal to 0. It means that nitrogen should be +4. Okay, another one, we could have NH4 plus. Okay, so we know hydrogen, but we don't know nitrogen. So nitrogen plus 4 hydrogen, and hydrogen has only 2 cases, the regular one, which is +1, and with metal. We don't have metal here, so this one will be +1. This should be equal to the charge of the ion, which is +1. So the sum of the oxidation number for all elements will be equal to the charge if you have a charge. If you don't have a charge, so it will be equal to 0. So it means this one, the nitrogen will be equal to +1 minus 4, so it will be -3. Let's take ClO4 negative. So here we have chlorine, it's unknown, and we have 4 for oxygen, and each one of them for oxygen, and each one of them was -2. This should be equal to -1, which is the charge of the ion here. So it means that the chlorine will be +7. And so on. So you need only to use rules to determine the oxidation number for each one of them. Okay, so now we will start with electrochemistry. So what is the electrochemistry? Actually, if we check the word here, we have two words here. We have electro, it means electrical, and we have chemistry or chemical. So we have electrical energy and we have chemical energy. It means that when you convert between electrical energy and the chemical energy, so it means that you have electrochemistry. So it's the term or the case when we convert between electrical and the chemical energy. Okay, so how to convert between electrical and the chemical energy? We will use something called electrochemical cell. So what is the electrochemical cell? It's the instrument that it's used to convert between electrical and the chemical. So we can convert electrical energy into a chemical reaction or convert a chemical reaction into electrical chemistry, electrical energy. Okay, so we have types. So if we will convert from chemical into electrical or electrical from chemical into chemical, so it means we have types here. The first type, it's called a voltaic cell or galvanic cell. And the second type is called electrolytic cell. So for the voltaic or galvanic cell, here we will convert a chemical reaction into electrical energy. So we will start by a chemical reaction and we will get an electrical energy. For the electrolytic cell, no, we will start with an electrical energy and we will get a chemical reaction. So we will convert a electrical energy into chemical reaction. And here for the voltaic cell or the galvanic cell, we have an application, an important application, which is battery. So we have battery here, and batteries actually is an application for the voltaic cell or the galvanic cell when we have a chemical reaction and we will get an electrical energy or a current from this cell. Okay, so let's talk about batteries here. So what do you need to know about batteries? First, with a classification of batteries, we have two classifications of batteries. The first one, which is the primary and secondary. So what's the difference between them? Primary is a battery where you can get electrical current from a not reversed reaction. So the reaction here is not reversed. It means this one is not rechargeable. So you can use it once and just you can get rid of it. Okay, it's only for once. Okay, you can use it only one time. So this one is not rechargeable. Okay, example for this one, it's a dry cell. Okay, which contains Zn and silver battery. Okay, for the secondary, of course, this one is a reversible reaction. So it means we can use it many times. So this one is rechargeable. Okay, and we need to know examples for this one, which is lead acid battery. This is the one used in cars. Okay, and lithium battery, and this one is used in your laptop. Okay, and we have a third, it's not unkind, but you need to know it, which is a fuel cell. What about the fuel cell? Fuel cell is a cell that uses the hydrogen and oxygen, the reaction between hydrogen and oxygen, and by this reaction you will get H2O and you will get a lot of energy. Electrical energy, of course. Okay, so this will be used the reaction between hydrogen and oxygen. And this one is used actually, and this one is not used, it's not common because it's very expensive. let's talk again about the voltaic cell. So we didn't finish voltaic cell. So what do you need to know about voltaic cell or galvanic cell? So it has two names here. First, you need to know the structure of the galvanic or the voltaic cell, and you need to know how to calculate the voltage of this one. So the structure, we will have two compartments or two parts. Okay, each one of them will have reaction. So one of them will have the oxidation, one of them will have the reduction. Okay, so it will be consist of an electrode. So this one was just a metal, and this metal is an electrode. So we have two metals in each compartment. Okay, and this metal will be immersed in a solution of the metal. So if I take this one like Zn, so here we will have a solution for Zn. If we have this one Cu, so we will have a solution for Cu here. And we need to connect between the two compartments with a glass tube, and this glass tube was called a salt bridge. Why it's called a salt bridge? Because it will contain electrolyte, which is ionic compound, like a solution of ionic compound like KNO3 or NaNO3 or KCl. So we need a solution for an electrolyte. It means a solution for ionic compound. And we will have a wire here, and then we will have a wire and maybe a voltmeter to measure the current. So first we need to determine which one will be the anode, which one will be the cathode. So if we assume that this one will be the anode, so at the anode we will have the oxidation. And so Cu will be the cathode here, and at the cathode we will have reduction. So you need to know that at the anode you will have an oxidation, at the cathode you will have the reduction. And the electron will be always moving from the anode to the cathode, and the electrons will be moving through the wire. So we have wire here. So electrons will be always moving from the anode to cathode, and they will moving through wire. But ions will moving through the salt bridge. So here Zn will be oxidized. It means Zn will be converted to Zn2 plus 2 electrons. So oxidation means losing electrons. So we will lose electrons. That's why here this is the source of electrons here. Okay, so it means after a time this anode will be reduced. It means the mass, I will not say this one, the mass is reduced or the mass is decreased. So the mass of the Zn will be decreased. And here Cu will be reduced. It means Cu2 plus will gain 2 electrons and deposit in the cathode. So it means the cathode here mass is increased. So you need to determine first the path of the pathway for the electrons. It will be on the through the wire from the anode to the cathode, and the ions will be moving through the salt bridge. And which one of them will be the anode, which one will be of them will be the cathode. Actually, to determine which one will be the anode and the cathode, you will give them something called reduction potential. So we have something called here reduction. So what is the reduction potential? It's the ability for the substance to be reduced, or the ability of a metal to be reduced. Okay, so this ability of the metal to be reduced will be measured by volt, and it will be given the annotation E naught, and it will be measured in volt. And scientists agree to measure this one. They will be measured compared to a reference, and this reference is called the standard hydrogen potential. So it means that all metals will be measured compared to hydrogen, and we will take hydrogen as a standard. It means the hydrogen will be 0. So he will ask about which element is, or what is the standard potential. The standard potential is the standard or the reduction potential for hydrogen, and this one will be always equal to 0 volt. And by comparing elements to hydrogens, we will get the value for each one. So we will get the value for all elements. So we will have the value for Zn, and we will have the value for Cu, and we can compare between them. The highest value is the cathode. So the highest value here will be the cathode and the lowest value will be the anode. And from this one, we can calculate the E of the cell, which is the cell potential. So the cell potential will give you the ability or the voltage it will be produced by the cell. So the cell potential will be calculated by E of the cathode minus E of the anode. So we need first to calculate which one will be the cathode. It's the highest one, and we need only to subtract between them, between E of the cathode and E of the anode. And when you calculate E of the cell or the cell potential, this will be called cell potential. You will get a value, and this value could be a positive value or a negative value. If it's a positive value, so this reaction will be spontaneous. If it's a negative value, so this reaction will be non-spontaneous. And this one is very important. This part is very important because he will give you a cell and he will ask if this cell will be spontaneous or non-spontaneous. So let's go back again for the Zn and see if the Zn and Cu batteries that we draw, or Cn and Cl and Cu that we draw a cell or which is composed of Zn and Cu. Let's take the E potential for each one of them. For E of the Zn will be equal to minus 0.76 volt, and E of Cu will be equal to plus 0.34 volt. Okay, here if we check here, this one will be the highest value. So this one will be the cathode and this one will be the anode. So we need to calculate the potential of the cell. So it will be E cell will be equal to the cathode, which is 0.34 minus, so it will be plus 0.67. So this one will be 1.1 volt. So this will be the cell potential, and it's a positive value, means this reaction or this cell is spontaneous. Spontaneous reaction means whenever you will just form the cell and prepare your cell, it will be directly giving you a current. Okay, the last part here before we start to solve problems, we need to know that we have for the electrolytic cell, or before talking about the electrolytic, we will talk about the applications of galvanic cell or voltaic cell. Okay, so first we have a corrosion, and we know that corrosion is loss of a metal by oxidation reduction reaction. So your metal will react with the oxygen of air, and so it will be you will lose your metal because it will convert it to a very brown layer, and this layer will be very brittle, so it will be losing the metal. And if you keep your metal in the air, so it will be react with oxygen. So we need to prevent this reaction. So to prevent this reaction, we need to make a protection, and the protection may be by painting. And of course, painting is not very beneficial because after time also the paint will be react with oxygen and react with air. The second one, which is very important, which is galvanization. And galvanization, it means that we will coat this metal with a layer of zinc. And this one is more effective. Okay, now we will talk about application of electrolytic cell. So electrolytic cell, if you remember, it's when you convert an electric current or electrical energy to a chemical reaction. So what is the applications here? First, electrolysis. of any substance. So what is the electrolysis? It means the separation of a substance, and the most common one like NaCl. So electrolysis of NaCl, it means that you will separate between the two elements. So here it's separation of the element involved in your compound. It means that you need to separate between sodium and the chlorine. So you will make an electrolysis of NaCl. So you will get Na and you will get Cl2. You will get two elements, sodium and chlorine gas. Okay, electroplating. So electroplating of a metal of an object with another metal, like with Ag or Au. Here, so the electroplating of any object with silver or with gold. Third, Hall Hurlet process, and this process is used to produce aluminum from the electrolysis of Al2O3, and it's used in industry. And the last one, which is down cell, and down cell is the cell used to electrolysis for NaCl to produce sodium and chlorine. Okay, let's start with solving some questions. And of course, I will put the link for this worksheet in the under the video. Okay, so let's start here. Maybe for the first one. Okay, oxidation potential is the tendency of losing to lose electrons. So oxidation is losing electrons. So I will take A because we know that oxidation is lose electrons. So we will take lose electrons. Okay, if the element is oxidized, it means the oxidation number will increase. So it will be also A. Okay. Which of the following is oxidation reaction? So to be oxidation reaction means that you will lose electrons. So I will search for some element, it will use electrons. It means oxidation number will increase. So here this is a pure element, so it will be 0, and here it will be minus, so it's decreased. Here it will be plus, and 0, it's also decreased. Here it will be 0 to -1, it's also decreased. So the only one increase, it will be D. What happened by oxidizing to the oxidizing agent? So the oxidizing agent, it will be reduced, so it will be a reduction. So the element is a strong oxidizing agent. Which element will be oxidizing a strong oxidizing agent? To be a strong oxidizing agent means that will be reduced, and to be reduced, it means that you will have a high electronegativity. What happened to chlorine in this reaction? So chlorine gain electron, it means a reduction. Okay, I will move to 18. So oxidation number of nitrogen in this one. So we know that hydrogen will be +1, nitrogen is unknown, and for oxygen we know that it's -2, but times 3. So it will be -6, +1, it will be -5, and it should be equal to 0, so it will be +5. Oxidation number for nitrogen, this one, so it will be +1 for hydrogen, and plus nitrogen, +2 for 2 minus for each oxygen, it will be equal to 0. If you solve this one, so it means it will be +3. Okay, this one is very repeated questions. Oxidation number for chromium and CrO4 2 minus, so it will be chromium, which is unknown, and we have 4 oxygen, each one of them is -2. This should be equal to 2 minus. It means it will be so here it will be +8. And also he could ask about Cr2O4, okay? Oxidation number of oxygen in OF2. Okay, so in this one, oxygen will be the unknown, and we know that fluorine is always -1. We have 2 fluorine atoms, so it will be equal to 0. It means the oxygen will be +2. The study of the process by which a chemical energy is converted into electrical. So chemical and converted to electrical, it means it will be electrochemistry. The ability of the substance to gain electrons, so this one will be a reduction potential. The standard potential, it will be 0, which is the reduction potential for hydrogen. Galvanic cells, electrons move through, okay, the electrons will move through the wire. In the galvanic cell, ions will move through the salt bridge, and we need to check here. We're talking about electrons, so it will be moved through wire. If we're talking about ions, it will be moving through the salt bridge, which represents the E potential. Here you ask about the formula. So the E of the formula for E of the cell or the cell potential, E, it will be equal to E cathode minus E anode. Okay, so the reducing agent here means the substance will be oxidized. So we need to check which one will be oxidized. It means which one the oxidation number of it will be increased. So we need to check the oxidation number for each one. For hydrogen, it will be +1. So it means if we calculate it for sulfur, it will be -2. For chlorine, it will be 0. Sulfur, it's an element, it will be 0. Hydrogen, it will be the same, +1. So chlorine, it will be -1. So which one, the oxidation number of it is increased, it will be S. If we check S was -2, now to convert it to 0, it means oxidation number increased. So this one is oxidized. So this one is a reducing agent. Okay, which is the cathode in this reaction? So the cathode, it means the one that is reduced. So again, we need to check which one is reduced. So Al converted to Al plus, so the oxidation number increased. It means this one is oxidized. Sn change from +2 and to 0. It means the oxidation number here is reduced or decreased. So this one is reduction. So this one will be the cathode Sn2 plus. The oxidizing agent, again, oxidizing agent means the substance will be reduced. So the substance will gain electrons. It means the oxidation number will decrease. So Na is 0 because it's an element. Br, it's in 0. Okay, Na is +1 and Br is -1. So if we check, we will see that Br is reduced because the oxidation number is decreased. So this one will be the oxidizing agent. So it will be Br2. Here for spontaneous reaction, the cell potential will be a positive value. Okay, so for here, calculate the cell potential for the following. We have cell. This is the reaction for the cell, and we need to calculate the cell potential for it. So from this reaction, we need to check which one will be the cathode, which one will be the anode, or we can compare between the value. So if we see here Sn was B0 and convert it to +1, it means this one oxidized, and the reducing agent will be Cu. Cu is reduced and Sn will be oxidized. So it means a reduction, which is the cathode, 0.3 minus 0.1, so it will be 0.4 with a positive value. Okay, for the same cell, he asked if this cell will be spontaneous or non-spontaneous. So we calculated before and it was a positive value, so it means this one will be spontaneous. Okay, cells that depends on reversible reaction. So reversible reaction, it will be a secondary cell. Which cell is used to obtain Al? So to obtain Al in the industry, we will use whole process, which is electrolysis of Al. Okay, which is not from electrolysis application. Also, this one is a repeated question. Electrolysis application, okay, for the electrolysis application, down is electrolysis application, whole process electrolysis application, galvanization, it's an application for electrolysis. So halogenation is a reaction. So this one is not an application for the electrolysis. Electrolysis can separate molten sodium chloride to get. So here you are separating the two elements. So you will get sodium and you will get chlorine. So I will get sodium and the chlorine gas. Which element is reduced easier? Okay, so here this one is missing. You should have the value for the reduction potential for each one of them. And the one with the highest reduction potential, so this one should be easier to reduce. So I think here we have missing some information here. Okay, what happens to the reducing agent? So reducing agent will be oxidation. Okay, which battery has a reversible reaction? So again, a reversible reaction will be a secondary battery. So don't go with names. Okay, only the reversible, it will be a lithium and lead acid. Okay, which happen at the cathode in the electrochemical. So for the cathode, we will have a reduction. So process of coating. So coating is galvanization with layer of zinc. So it will be to prevent corrosion. Okay, the reduction potential for hydrogen is 0, which is called the standard. Okay, the cell potential is spontaneous. It will be a positive value, so it will be C.